You're halfway through the paper and this is your birthday question. So although it's for 5 marks, the examiner simply wants you to show your step-by-step workings. You should be able to eyeball the solution to the differential of a quadratic in its standard form. It's always in a linear equation, in our case 6x plus 2. But the key phrase in this question is from first principles. So we're going to start with the general formula of a differential. The differential of x equals the limit as h tends to 0 of f of x plus h minus f of x all over h. Right, so just substitute in our numbers. So for f of x equals 3x squared plus 2x, and f of h plus x equals 3 times x plus h squared plus 2 times x plus h. Expand this and you get f of x plus h equals 3x squared plus 6xh plus 3h squared plus 2x plus 2h. The differential of x equals the limit as h tends to 0 of 3x squared plus 6xh plus 3h squared plus 2x plus 2h minus 3x squared minus 2x all over h. So gather the terms. And the differential of x equals the limit as h tends to 0 of 6xh 3h squared plus 2h all over h. Now divide the numerator and the denominator by h and we get the differential of x equals the limit as h tends to 0 of 6 times x plus 3h plus 2. The differential of x then equals 6x plus 2. And it's proved from first principles. Here's a second gift for 4 marks. This is simple differentiation. They're just going to try to catch you out on the signs and the arithmetic. Okay, so from the power rule, we know that if f of x is x to the n, then the differential of f of x is n times x to the n minus 1. And from the sum rule, we know that if f of x equals g of x plus h of x, then the differential of f of x equals the differential of g of x plus the differential of h of x. In our question, y equals minus x to the power minus x minus 1 plus x to the power 1 over 2, we're going to deal with the terms separately. The differential of x to the minus 1 is minus 1 times x to the minus 1 minus 1, or minus x to the minus 2. Cancel out the negative signs and you get plus x to the minus 2. In the second term, x to the 1 over 2, then the differential of x is 1 over 2 times x to the 1 over 2 minus 1, or 1 over 2 times x to the minus 1 over 2.